Welcome. This is Bill Baker, and this presentation is for the Coursera Introduction to Interactive Programming in Python. The name of this presentation is A Moment of Randomness. Okay, now this will be short and painless, so sit back and enjoy the topics. First topic that we're going to talk about is seeding the random generator. And you may know in CodeSkulptor that there's a nice feature for the documentation. If you go and select the standard module tab and then scroll down to random module, you'll find out that there's a function called seed the random number generator. Okay, in reading that documentation, you can see that every time you import the random function, this seed is set with the system clock. And if you call this function, it would default to the system time, but you can also supply an argument. An optional argument can be any hashable object. So that could be like any number that you might choose. Okay, how might you use this in a program? If we go back to the code area, you can see here the simple program. It just prints out two random sequences. And what you see here, looking at the results, sequence number 1, scanning down, it appears to be random within the sequence, and the sequence number 2, a different sequence, also appears to be random. But what if we use that the seed function to set a starting point for these sequences? So I'm going to choose an arbitrary number, and this randomly selected, pun intended there. I'm going to select 123. You set this for each sequence, and then look at the result, if you can type it correctly. Okay, the sequence within sequence 1, yes, it appears to be random. Sequence 2, you notice sequence 2 exactly matches sequence 1. And that's a result of setting the seed. Now, the takeaway here is that you want to be very careful if you're using this programming for scientific purposes. You want to be very careful on the seed that's chosen. Second topic is uniform versus non-uniform distribution, and we're going to look at some dice examples. Example number 1 here. What we're doing is we're rolling the die or the dice and then putting the value from 1 to 10, 11 to 20, 21 to 30 into a bin to count the number of occurrences that occur within that distribution. So the first example is rolling a 12-sided die. Second example is rolling a more commonly used pair of dice, 1 through 6, and then adding the result together like you might play in some dice game. And then we're keeping track in this bin list. We're keeping track of the number of occurrences. And we're running this 10,000 times. If you notice the little pause there between the time I clicked it and the results popped up, because it's doing 10,000 of these random number generations times 2. So you see, within this first example, it's pretty uniform. It's all in the 800 range. Number 9 appeared 799 times, but most part it's pretty uniform. What you see in the second example, though, is that it starts low, it peaks between 5, 6, 7, and 8, and then it starts going down. So this would be an example of a bell curve occurring because you're adding two 6-sided dice together. Okay, and then the last topic here is some books about random numbers. If you've ever taken the time to check out Amazon and what they have for random numbers, the results are pretty funny. Do a search for random numbers and search in the books section. You can see the very first one that comes up is a million random digits. You can see it's sort of a pricey book. You can go and look at the Amazon feature that can show you a couple pages of this, and it's page after page after page of random numbers all nicely formatted in a table. Looks like they're in groups of 5. And it just goes on page after page, as you can scroll through and see. Okay, might want to check and see. This book was written or published in October 2001. So I'm wondering if there have been any books that follow this. So if you go back to your search screen, you can scroll down. You can see several books about random numbers. There, right there. A Million Random Digits, the sequel. This is like a series of blockbuster movies that might come out. So at some point they issued a new book here with a new feature. It promises that this has perfectly uniform distribution of the random numbers. And looking at the contents like before, you see it's page after page of randomly generated numbers. Now this is pseudo-random numbers, and in fact pseudo is misspelled, but it leaves you to believe that they probably used a computer program to generate these numbers. Whereas maybe in the first book they used some sort of physical input to generate the random numbers. If you ever take the time to read the comments here, they're pretty hysterical. You can see, for example, this one, the review is titled, "To be shared with any number of friends." I was left wondering if I would have chosen 0 or 1, but the sequels persuaded me that there are other digits to choose from, much more valuable. And so this certainly book enriched their life. The second comment here that's pretty funny is the only self-help book that you'll ever need. This real page-turner with constant surprises, as you would hope for in a random number book. The sequel, let's hope that doesn't mean it's the end of this series. So thank you for spending time. If you were interested in the code examples, here